Today we are going to learn about box plots. A box plot, also called a box and whisker plot, uses a number line to show the distribution of a set of data by using the median, quartiles, and extreme values. Extreme values are the smallest and the biggest numbers in your data set that are not outliers. A box is drawn around the quartile values, and the whiskers extend from each quartile to the extreme data points, again, that are not outliers. The median is marked with the vertical line. So to put all of that into a visual for you, you can see a box and whisker plot here, or a box plot. You have the lower extreme down here. That's the smallest number that is not an outlier. Your upper extreme is right up here. That's the biggest number in your data set that is not an outlier. And then, of course, we have our first quartile, our third quartile, and our median. And one thing you're going to love about box plots is that the outlier is really clear for you. Any outliers are marked really clearly. You can see over here that 330 is an outlier. It's way bigger than the rest of our data. So box plots separate data into 4 parts. Even though the parts may differ in length, like in appearance, each part contains 25% of the data. So from the lower extreme to Q1, that's 25%. From Q1 to the median, that's 25%. From the median to Q3, that's 25%. And then from Q3 to your upper extreme, that's 25%. So that creates a total of 100%. The box shows the middle 50% of the data. So let's try writing a box plot. Represent the car's speed data in a box plot. The first step is to order the numbers from least to greatest. So let's go ahead and do that. Alright, so it goes from 19 all the way up to 40. Step 2 is to draw a number line that covers the range of the data. Now this step has already been done for us down at the bottom of the page, so we don't need to do that on this specific problem. Step 3 is to find the median, the extremes, and remember, extremes are the smallest numbers and the largest numbers in our data sets that are not outliers, and then the first and third quartiles. So let's do this. We need to find median. We need to find Q1, Q3, and then we need to find if there are any outliers, and then that will tell us what our low extreme and our high extreme are. Okay, so I want you to go ahead and pause the video to find the median, your first and third quartiles, and the outliers, and then we'll do the low and high extremes together. Press play when you're ready to continue. Okay, so the median was 25, the first quartile was 22, and the third quartile was 34. Now, to find our outliers, remember we find the IQR, which is what I did here, and then multiply it by 1.5 to get our helper number. 18 is the helper number, and then to find the lower limit, we do Q1 minus the helper number, so 4 is the lower limit, and then to get our upper limit, we do Q3 plus the helper number. 52 is our upper limit. So any numbers in our data set that are lower than 4 or higher than 52 are outliers. And as I look, I don't see any of those. So no outliers. That means our low extreme is going to be 19 because that's the smallest number in our data set and it's not an outlier. And the high extreme is 40 because it's the biggest number in our data set and it's not an outlier. Step 4 is to draw the box. I skipped something. Now we have to mark the points. So we wrote the points, we wrote those values, but we have to mark the points above the number line. So let's go ahead and do that. Down at the bottom of the page on our number line, we're going to put a dot above the 25 for the median, a dot above 22 for Q1, a dot above 34 for Q3, and then we're going to do a dot above the 19 for our low extreme, and a dot above the 40 for the high extreme. Now we can go to step 4, which is to draw the box so that it includes the quartile values. So here's what we do. We are going to draw a box from quartile 1 around the median to quartile 3. And then we're going to put a vertical line through the median right there. And then we're going to put little whiskers. This is step 5. We're going to extend whiskers from each quartile. So I just went from quartile 3 to the high extreme. And then I'm going from quartile 1 to the low extreme. And so this is our box plot. So let's make some labels on here, just so you know. Now you can see what each part of the box plot is. We have our low extreme down here. Q1 is this line. This is our median. This is Q3, and this is the high extreme. Now you won't have to do that on the other box plots you make, but just in your notes it's nice to know what each part of the box plot is. All right, interpreting box plots. It says refer to the box plot in problem 1, so I've put a little picture of that up here. It's asking us half of the drivers were driving faster than what speed. Well, when it asks us that, that means we need to look at the median. So right here tells us to look at the median. Well, our median was 25, so half of the drivers were driving faster than what speed? Well, 25. Half of the drivers were driving faster than 25 miles per hour. What does the box plot's length tell us about the data? Now this is interesting. If we look at our box plot, the left half of the box plot is a lot shorter than the right half. Even though they both represent 50% of the data, the left side is a lot shorter. That means that the data on the left side is a lot more crunched together. It's more concentrated. And then of course, the right side of our box plot is a little bit longer. That means the speeds of the fastest half are more spread out. What percent were driving faster than 34 miles per hour? Well, 34 was our third quartile. So we want to know what percent were driving faster than 34. Well, remember, each part of that box plot represents 25%. So from Q3 all the way up to our high extreme, so from here to here, that represents 25%. Okay, so 25% were driving faster than 34 miles per hour. The box plot below shows the daily attendance at a fitness club. Determine the median and the measures of spread, then interpret the data. So what I would like for you to do is find the median, first and third quartiles, and the IQR on your own, and then we'll talk about outliers when we come back. So go ahead and pause the video, find median, first and third quartiles, and the IQR on your own, and then press play. To find the median here, we're looking at the middle of the box plot, and I just drew a line straight down to my number line, and I see that it's halfway between 70 and 75. So we're going to have to do 70 plus 75 divided by 2, and that gives us 72.5 or 72.5. The first quartile is that first line of our box plot, so I drew a pink line to represent that, and that goes down to 65. So the first quartile is 65. And then the third quartile is that third vertical line in our box plot. So I drew a line down to the number line so it would be easy to see that that is 80. And then our IQR is Q3 minus Q1, which I got as 15. Now you guys are going to love this. Okay, here is the best thing ever about our box plots. So with box plots, you don't have to do the calculating for the outliers. You don't have to find a helper number, and you don't have to find your limits. Oh, it's the best. Because look, this little asterisk over here, this little star, that is an outlier. And that's right above 110, so any outliers in this data set, super easy to see. The outlier here is 110. Isn't that the best thing ever? This is why I love box plots. So guys, we'll practice these when we come back in class tomorrow. Have a good night.